Hi, this is Cody H, and I'm going to be talking about something in a science book. As you already see, I'm going to be talking about wave interactions, which was in the first chapter of the third section of this book. So far, I'm going to be talking about what's the difference between constructive and deconstructive interference. And I'm also going to be talking about resonance. Let's go through that now. First would be constructive interference. As you can see, constructive interference is when two or more waves combine that are either both above or below the still line. And the still line is sort of an imaginary line that when you can't hear, or it's basically where you can't hear. But if you have above lines, that means it's sort of the start of the note. But then when you do the below lines, it would be as of the reflecting of the sound of the notes. Okay, as constructive interference is a combination of two waves that are either above or below the still line. Like a tornado, hot air rises up to the top of the funnel and goes down, which becomes cold air, or never mind. As the cold air comes down, it escapes through the little shafts at the bottom. That way, it comes up as hot air, and the cycle repeats over and over and over. Now it's sort of like the hot air or above lines is the start. It's like a start of a sound. But then the cold air or below lines are the reflectings of the sound. Yet the whole tornado or the still line, you cannot hear anything, so nothing goes through. Now I'm going to be talking about deconstructive interference. Deconstructive interference is the combinations of two waves, but this is its weird part. One wave is either above the still line, and one wave is below the still line. Now it's kind of confusing, but it also kind of works. It's sort of like gravity. Gravity, or the above line, pushes something down to keep it on Earth. But sometimes when you're in the air resistance or below lines are coming up to reflect you or slow you down. Because if you didn't have any air resistance or below lines, as in this picture, you would just fall. You would just go up, and then you will go down about 10 times faster than you actually are. Now that's why, because air resistance has slowed down the acceleration of you, but gravity is trying to put up the acceleration. So as it says, it would mean that it would either, in space, gravity and air resistance would be the same, which would mean you would go nowhere. But since how it's on Earth, the gravity is just a little bit more than air resistance, so you go down. Now we are going to now talk about resonance. Resonance is basically when it's all about vibration, and it's when two or more objects vibrate at the same frequency or speed. Or it could be a phenomenon when an object, based on just its vibration, will appear to vibrate another object without the other object vibrating. Now see, as you can see in here, it's sort of like tuning forks. As on the left side, you can see that it can vibrate at the same time as both. So both would be vibrating at the same time. So that would be one type of resonance. But as you can see on the right side, it's not the same type of resonance. So this fork is actually going so high of resonance that it is making this tuning fork that's not vibrating at all suddenly starting, because the big tuning fork has a vibration so big, or resonance, that it is making another smaller resonance start. Now, as we can see to our final one, here's some questions that you might want to think of. Are all the waves the same? Do they all use or are used for the same purposes? Or why are there so many names for waves? Now just think about it. Why? Because think about it. If you just see a wave, do you think that every other wave is the same thing as that one? And do all the waves serve the same purposes? If two waves, they might, I'm just thinking that they might be doing different ones, but waves are also doing the same. So are they all used by or for the same purposes? And number 3, why are there so many names for waves? Why can't there only be one name for a whole bunch of waves? Because they would all be the same. Now these questions are some that I am still trying to find out. Also, because all these questions, I thought of stuff, and in my head of these questions, I was thinking, are these questions that the people that are watching or hearing this right now, would they be thinking of it? And also, would I try to be thinking of finding the answer? Now, as of this, it would be confusing. For we would have to figure out why, or could all the waves be the same thing? Are they all used for the same purposes? And why are there so many names for waves? And that has brought us to the end of our paper slideshow, if you think. So basically, I might be making another one, I might not. But for so far, this is Cody Hewitson signing out.